Welcome back to Physics 150. This is Dr. Dave. Many students are having some difficulty this week as we get into understanding free body diagrams and forces. They're having difficulties adding vectors together. So I just wanted to run through a couple examples on how to do that. Some students have seen vectors in high school, some haven't. And while I think the textbook does a pretty decent job of outlining how it's supposed to work, not everyone's been able to follow that. So let's just run through a couple of quick examples of how do we add vectors. First off, what is a vector? A vector is something that carries magnitude and direction. Maybe that doesn't mean a whole lot to you. Well, let's imagine I said you're traveling 50 miles per hour north. 50 miles per hour is the length of the vector, and north is the direction. Same thing is happening here. Forces are telling us how much force are you pushing with, which we measure in newtons, and in what direction. So let's imagine I had three vectors, vector A, vector B, and vector C. Right? Each of these vectors is independent. They each have their own length, and they each have their own direction. So if I ask you to add together vectors A and B, I think many people can probably do that now. Just to review, what you do is you take the first vector and you draw it, and at the head of that vector you place the tail of the second vector. So now the question is, what do you do at this point? Well, what you do is you say, I started here at that location, and I ended here at that location. The new vector that you're drawing is going to be this from the start of the first vector to the stop of the second vector. So that is vector A plus B. So let's do another one. Let's say I now have vector B plus C. These are the original vectors. So I'm just taking my vector B, transporting it over here, vector C, transporting it over here. And again, I'm placing vector C at the end of vector B. So what is the solution? Well, I started here, I ended here, so I'm drawing my new vector as the line between those two. And so this is vector B plus vector C. So I think most students understand that and are able to do it. The difficult part comes in, what about when there's three? Vector A plus vector B plus vector C. Well, let's do that a little bit more carefully. So if I wanted to do now A plus B plus C, which vector would I start with? Would it matter? Turns out it won't. We'll see why. So I will start with vector A. At the end of vector A, I'll place vector B. Now, what do? Well, if you wanted, you could add these two together, but let's save ourselves a little bit of time and do the third vector on there as well, vector C. So we're just going to place a long chain. So we started at this location, we ended at that location. So the vector addition is just from the start all the way to the finished. Oops. And that is A plus B plus C. Now I said it wouldn't matter what order I added them in, and it turns out it won't. Why is that? Well, let's imagine instead I did B plus C plus A. So now I will start with my vector B. I will add to it my vector C. And now I will add to it my vector A. And so I go back to where I began, where I end, and I draw my new vector there. And there we go. That's vector A plus B plus C. We get the same answer from here to here. What's around them might look different, but the start and stop point will be the same. So when you're doing free body diagrams, one of the things you want to make sure you do is that you add all the vectors on your free body diagram together to make sure you know the direction of the net of all those forces. I'm also going to post online a couple of extra vector problems that I recommend everybody practice with. Go through these, add these different vectors together in the order of operations given here. This will be a PDF on Moodle. If you can do that, there is nothing with vectors I can give you that you can't do. Thanks for taking the time to watch this video. Please do reach out if you have additional questions.